Good evening, all. Welcome to NPTEL online certification program. This is the course for a online certification program of NPTEL Biophotonics, and I will be the TA of your course. I will introduce myself. I am Jijit, one of the PhD scholars in IIT Madras, who will be acting as a TA for this particular course. My main area of research is actually protein biophysics using single molecule for spectroscopy, mainly using optical tensor. Okay, let us start the discussion. What we will do, hope you people are already gone through the lectures. Today we will see what has happened in the week 10 the lectures, and we will try to solve some model questions such that that will be useful for you to solve this your assignments, and it will be useful for your exam also. So we will go through different questions. While going through the each questions, what we will do, we will actually look what are the knowledge we will gain through that lectures. Okay, wait for some work. Sometimes it's that people want to join the let them join and we'll start. Okay. Okay, let's start. In last week video, actually, it was discussed about optical tweezer, optical scissors, and optical manipulators kind of thing. So what we are using light, and we are trying to manipulate the mechanical particles. So what is the funda here? The light can produce mechanical force. That's the thing. And how we can use light to produce a mechanical force. That's actually which we are going to study in this, which we already studied in this week, and we will see how it will happen. So we will go through the questions. As we going through that questions, we will understand what are the things has to understand. Okay, we'll start from the basic itself. So let us the questions will go in such a way that optical teasing action is based on force arises from the change in energy of the photons, forces arising from the change in the momentum of light. Both change in energy and momentum of light causes teasing action. None of this. So these are the first question is optical teasing action is based on. And the options forces arising from the change in energy of the photons, forces arising from the change in momentum of the light. Both change in energy and momentum of light cause teasing action. None of this. And we will see how to find out the answer of this question. Okay, so we'll see how an optical tweezer works. So we already see that what we want. Now we want so just understand that just consider the photons. So photons are actually energy particles. Like quanta of light is actually called photons. So instead of considering just I'm saying this is a particle of photons. So actually we cannot put any photon like this way. This will have wave nature as well as particle nature. So I'll say that it is a quanta of light which has a wave nature as well as a it's an energy packet. You cannot draw like this way. Okay. So I'm not drawing. So I'm just representing it as something, some energy packet with some small wave property, something like that. Okay. So this is composed of photons having a particular wavelength. And the energy of the photon can be defined as E is equal to h nu. So nu is the frequency of the wavelength and h is a Planck's constant. So a photon having a particular packet or the particular wave packet or a particular energy packet has a fixed energy that you cannot even change. Okay, so that particular photon is composed of that photon characteristic is that's energy itself or energy or wavelength you can say. So similar thing which you can write hc by lambda. Okay, so this is the characteristics of the photons. So what happens if in the case of photons, if we say that photon will travel In vacuum or in air, it will travel with the velocity c. Considering there is no medium here at all or the air, you can consider that photon is traveling at the speed of c, it's the velocity of light. And when it is interacting, and is interacting with the particle, what happens? It can change. Just consider that some refraction is happening. So, or it is some reflection is happening. Photon will incident at a plane, it will reflect back. Whether the energy of the photon will get changed? No. Energy of the photon will be same as that one. And whether the momentum of the photon is changed? Yeah, actually, photon's momentum is changed because the direction of propagation is changed. So the momentum of the photon is changed. Usually, a single photon, we can define the photon momentum as P is equal to h by lambda. Okay, you can define as a photon momentum is P is equal to h by lambda. But here, we are not dealing with all this. These are actually the quantum mechanical concepts, but we are not at all going to use these concepts at all. Means we are actually using this concept, but to understand this one, you don't have to think about deep here. Just to think that the photon has a momentum and it can travel. When the direction of the photon is changes, the momentum of the photon also changes because the momentum is a vector quantity. So in the classical mechanics, what it is says, if there is a change in momentum, there will be an associated force according to that. So if the photon has a momentum and photon momentum is gone changed, that impart some force is experienced by the photons. And that means somebody exerted for force on photon. Similar thing, the Newton's law of force, third law of motion says that if there is an action force is applied, there should be a reaction force also. So if somebody applied force on photon, means that the photon is also applied some force on the other particle. So there will be a mutual action interaction force will be there, such that a particle can move. If there is a condition for movement is there, particle can move according to the action of the force. Okay, so it can move according to that. Now now see that, so I'm saying that photon is moving in this direction, so the momentum of the photon can be represented like this way. So after interacting with the something, I'm seeing that photon is moving in this direction. So definitely there is a change in momentum. So definitely there is a change in momentum. What is the meaning here? Change in momentum means there is some force is exerted on it. Just consider it as some classical particle, a ball. I am throwing a ball against a floor. Bench. The ball is hitting here and it is bounce. So what happened? So there is a hit here and ball changed its direction. That means there was a force exerted on the ball. Who exerted the force on the ball? The bench exerted force on the ball. So what happens? That's why the ball's direction got changed. What about the bench? When the ball hit on the bench, and if there is no other force is acting on the bench, even the bench can move a little bit downwards, because the when a force is exerted on the ball by the bench, the ball is also exerting a force on the bench. That is the Newton's third law of motion. So now we can understand, calculate how much force is exerted on the ball. That's actually that can be actually calculated using Newton's second law of motion, which is saying that force is equal to dp by dt. So if we can calculate the how much time that interaction happened for changing that momentum, and that will be the dt. And what was the change in momentum? What was the change in momentum? This is your initial momentum, and this is the final momentum. This is the final momentum. So I am here. I am using the vector algebra. So I put the same here. So this is the initial momentum. This is the final momentum. So this will be the change. So there is a change in momentum in this direction, and the change in momentum. So that means the force is exerted on the ball in this particular direction. So, and if you divided that time with the tiny time of the interaction, you will get how much force is exerted on the particle. Similar way, if the photon is interacting, if a photon is, just say that there is some particle or something. I'm saying photon is coming here, and after some time, photon is going like this way. So, what is the meaning? The photon has a change in momentum. It's initial momentum, so final momentum. So there is a change in moment in this direction. So there is a force associated with that particular change in momentum. So photon experienced a force in this direction. That means that if this is the particle which has exerted force on the photon, then the whole particle may have experienced a force in the other side direction. So if a photon is moving through a particle like this manner, there is a force is exerted on the particle which will move the particle in the opposite manner. Okay, this is the, so you can see that if there is no change of the overall energy of the photons may be getting changed. Overall energy means the stream of photons. That is actually not the energy term. That is actually the intensity term. So we can say that the energy of the photons are same. What is really matters and which is actually causing the fusing action, this is the change in momentum. So the momentum change of the photon is actually causing force arising from the change in energy of the photons. So this is wrong. The change in energy is not touch out going to arise force. Force arising from the change in momentum of the light. This is actually the correct answer. Both change in energy and momentum. Since this is wrong, so this is not going to be wrong. So the answer is C. Sorry, the answer is C. So that's the answer is B. Hope you people understand that one. So just think about that. Now let's move to our second question. Pick the incorrect statement. Optical teasers are non-invasive method for manipulation. So we already discussed that optical teasers. What is happening in the case of optical teaser? There will be using light and change in momentum. We are actually manipulating the particles. Particles can be either dielectric bead, or it can be an organelle, or it can be a bacteria, virus, or a cell, that kind of things. Usually we use a wavelength, which is a near infrared region. Why we are using near infrared region wavelength? Because this near infrared region wavelength is actually, we select the wavelength in such a way that it will not create any harmful to the cell, such that the whole energy, the cell will not absorb the whole energy, and it will not get heated or get destroyed. And we are also saying that okay, we are doing with some biological specimens and other things. Most of the biological specimens content will be mainly water. So if the water is going to absorb most of the energy from the light, so the required energy or the momentum we cannot actually transfer to the particle which we are interested in. So we are also have to say that it is not harmful to the cells also, and not absorbed by the water windows. So we usually use as a near infrared wavelength light, which has a, since it is not completely absorbed by the biological systems, you can actually use it for transmit more distance, as well as you can ensure the absorbance by the water molecules. So so we are actually saying that the interaction with the cell and getting damage to the cell is minimal. So this is obviously a non-invasive method of manipulation. So this is true. The statement is true. So this answer is not true. Near infrared laser beams can manipulate the cells without damaging them. So that's we already told. So that's the way which we are using near infrared wave. So this is also true. In optical scissoring action, light must simply pass through and molecules must not absorb the light. So, in the scissoring action, what we are supposed to do? The scissoring action, actually, we are cutting the cell. So, the target cell is getting cut or destroyed, or something portion is happening either on the cell or cell wall. So, it's not absorb the cell. If it is a cell is not absorbing, or it is not getting manipulated or getting cut, so that energy is not transferred, that is not happening. So the statement is not correct. The force exerted by the optical tissue is so weak that it cannot manipulate group of tissues. The force exerted by the optical tissue is actually weak force only, but it is not so weak that it cannot manipulate, because that is enough for manipulating even organelles and even tissues. So the statement, so force so weak that it cannot manipulate group of tissues. Yeah. So the thing is that it can manipulate some amount tissue, but if it is going a big group of tissue, it cannot get manipulated. But yeah, The most of the answer is, so this group of tissues can be depends on the size and other tissues. So this is a little bit confusion on this one. So, but we can say that the force x operates is so big that it cannot manipulate group of tissue. That is a doubtful manner. So we can put a doubt about this question. So this depend on the size of the tissues and other things. Sometimes the group of tissues can also be get manipulated if the power of the tweezer is so much. So the question is that the force exerted by the optical tweezer is so weak that it cannot manipulate a group of tissues. So the force will be in the piconewton range. So this can be used to move some cells, some organelles on the cells and other things. Sometimes this can come in such a way that we cannot even manipulate a group of tissues. Still, there is a question in that one, so that's a not a very precise. We cannot say, but if it's a big tissues and other things, we cannot manipulate the entire tissue with the optical tissue thing, because the force exerted by optical tissue come in the nano piconewton range. So the correct answer is, the answer is correct means the statement wrong statement is C. So the correct answer is C. Now going to the third question. The property of light that controls the overall movement of the particles in laser fusing. Wavelength of the light. So that actually depends on the particles and interaction of the particle. We will select the wavelength of the light. But the wavelength of the light is not the cause of the fusing action. So this is wrong. Frequency of the light. This wavelength and frequency are related in such a way that C by lambda is actually frequency, or C by n lambda is actually frequency, where n is the refractive index. So frequency of the light and wavelength of the light is almost matching. So what I told this actually in a particular medium. So frequency of the light we cannot say. This is the thing which is controlling the fusing action. Duration of the laser pulse. Laser pulse duration is not the one which is controlling the fusing action. The intensity of the light. So actually intensity means it's a number of photons. So each photon will change, cause a change in momentum, and that change in momentum is cause the fusing action. And if the intensity of the light is increasing, means a large number of photons are getting involved in that action, and change in momentum will be more. Similar way, the corresponding force also will be more, and the fusing action will be effective. Okay, so the answer is intensity of the light. Is there any doubt? Just think about these things and tell if there's any doubt. Going to the next question. Which of the following condition ensures the particle is trapped by a laser beam? So let us see what are the forces acting on a laser beam when it is using it as a optical tube. So when a particle is getting trapped, or when it is saying that it's getting trapped. So in the normal case, I'm saying that now we are actually ignoring the gravitational force and other things. So the particle is actually inside the laser beam. So the laser beam is passing through this one. So there will be some gradient force which is happening like this way. So because of the gradient force, there will be a force in this direction, which gives a net force in this direction. And there will be some scattering force which is coming because of the scattering of the light or the reflection of the light. So that will actually push the particle downside. So there will be scattering force in this direction. So if you are considering the particle as a some point mass or something, so the gradient force is in this direction and scattering force is in this direction. So when the gradient force and scattering forces are equal, so the net effect is that there is no force on the particle. So the particle will be stay at that position. Beyond that one, what are the forces acting on that? This is a mass, and if just think that if this is going downwards, if the arrangement is such a way that the earth is down, so there will be gravitation force which is towards downside. So the gravitational force will create weight on these particles. So weight will act in the downward direction, and so this whole particle can be immersed in particular liquid or the buffer or anything. So there will be a buoyant force which is upside of the particles. So there will be a gradient force and there is a scattering force, and there is a weight and there is a buoyant force. When these all forces are balancing each other, so the particle will stay there. So let us see here. So gradient force is equal to the scattering force and F gravity is equal to F buoyancy. So gradient force is greater than scattering force. F gravity is equal to F buoyancy. Yes, there you can see that here they put a gradient force is greater than scattering force and F gravity is equal to F buoyancy. So this is actually a confusing manner. We'll see that and how it is actually see. So in the proper equilibrium, actually all forces should cancel each other such that it's in the trapped. So trapped at the moment of trapped position, what's the net force on the particle is zero. If the net force on the particle is not zero, it can move. So if it is moving, then we cannot say it is a proper trapped. If it's a trapped equilibrium position, the net force should be zero. So I think this can also be an answer. If these are the all forces acting on the particle, then this is a matter of question. I will discuss with this NPTEL team and I may update that answer. Let's see. Okay. So in the normal circumstances, actually all forces should get balanced such that there will not be a net force at the trapping condition. So at the equilibrium condition, there will not be any net forces. So all the forces acting on the particles are actually mutually balanced. So there will not be any net force. So that you have to see. So let's check the next question. Statement 1. The power and wavelength of a laser determines how well a particular microscope objective can focus. The power and wavelength of a laser determine how well a particular microscope objective can focus the laser. A laser power between 20 and 100 milliwatt of the microscope is sufficient to carry out trapping experiments. The power and wavelength of a laser determines how well a particular microscope objective can focus the laser. So the focusing power of an objective lens is not at all depends on the power and wavelength of the laser light. So if the wavelength of the laser light is enough such that it can transmit through that material of the lens, then the power and the wavelength is doesn't matter. So the first statement is actually incorrect. So a laser power between 20 and 100 milliwatt at the microscope is sufficient to carry out the trapping experiment. So that is actually comparatively for the small particles. For small particles, a laser power between 20 and 100 milliwatt is enough to carry out the trapping experiment. So that thing we can say that that is correct. So this statement is correct. This statement is incorrect. Such that statement 1 is incorrect and statement 2 is correct. So option D is going to be the right answer. Why not heat generated in cold ablation process? So what is meant by cold ablation process? So we use a ultra fast laser pulse such that before the molecule getting vibrated, the molecule is detached from the surface or from that particular entity. So that is the basics behind a cold ablation process. So what happens? So there should be some thermal relaxation time such that the molecule will undergo thermal vibrations. So if the time or the energy supply time is more than thermal relaxation time, the particle can undergo thermal relaxation, thermal excitation, relaxation such that it can go in the vibration. But in the laser pulse, what happens? Within the thermal relaxation time, the laser pulse will be get active. So of the time cellular command is lesser than the pulse duration. The thermal relaxation time of the cellular command is higher than that of the pulse duration of the light. That's the thing. That means actually the laser pulse duration is lower than thermal relaxation time of the part. 1 minute. So the answer is thermal relaxation time or the pulse duration of the laser is actually shorter than the thermal relaxation time of the particle. So the answer is thermal relaxation time of the cellular component is higher than the pulse duration of the time. So without getting the time to get it vibrated and get transferred to the heat got transferred, the molecule is detached from the cellular environment. So that's called a cold ablation because that heat is not transferred. The heat is not experienced at all. So the answer is B. Next question. The parameter that help in controlling the depth of optical drilling are. So optical drilling is the process in which we use a laser beam or a focused laser beam to remove some of the particles from the cellular environment. It can be a small portion of the cell wall or some more inner portion or something like that. So what are the components which will help? Intensity of the laser. Properly it will help because that is actually depends on the how energetic your laser focus beam. Power of the laser. So that's actually if the power is increasing, what happens, the intensity of the laser is automatically getting increased. So that also true. Time of focusing the laser, that actually depends how much deep it can go, depends on the cellular environment. So that also the depth. So these all things are actually coming. So intensity of the laser is proper. Power of the laser is also good. So time of focusing of the laser is also good. So all of this, the answer of this question will come as all of this. So the next question, which of the following is used in the laser pressure catapulting process? This is actually a direct question which is dealt in our class itself. So the answer is nitrogen laser. So so UV laser, argon ion laser, excimer lasers are the lasers which depends on different purposes. So depends on the purposes and the requirement we can use different things. So usually in the laser pressure catapulting process, the usual laser which is used is nitrogen laser. Okay. Which of the following applications are laser scissor? Opto injection. So using light, you can use it as an injection. So putting some medicine or something, you can put a small hole and put the medicine or something. So this is actually true. Trapping of cell organelles. So that is not a laser scissor. Trapping means optical teaser. So this answer is false. Microsurgery. So surgery means you have to cut. So laser scissor can be used for cutting microsurgery. It's true. Micro dissection is also similar to surgery. This is a cutting end. So this can also use. Piecing of organic nanoparticles. So it's no optical drilling means making holes. That's also some kind of cutting you can say. So this is also true. So A, B, A, C, D, F. So the correct answers are A, C, D, and F. So these are the questions which these are the model questions which we are covering here. So if you have any doubt, just go through these questions, and if you have any doubt, just let me know. So let us have a summary of these sessions today which we have taken. So we started with optical teaser. Optical teaser. So in this week, actually, yeah, if you have summarized this contents of this week's course, so in this course, actually, we had optical teaser and optical scissors and some applications of that one. So optical teasers are the teaser or the optomechanical devices which use the principle of light carrying momentum, and change in momentum can be used as a force, and using the force you can manipulate the microscopic particles, and along with that one actually you can manipulate the particles attached with that one, or cells or organelles or something which you can actually manipulate. So this is the fundamentals of optical teaser thing, and optical teaser thing can be made use of a laser beam with a high numerical aperture objective and a condenser lens and some optical arrangements. So you can use the laser beam, you can manipulate the laser beam. So the focus of the laser beam also changed. Correspondingly, you can manipulate the trapped particles, and the particles get trapped at a position such that all the forces acting on the particle is getting balanced. So there is like gradient forces are there are scattering forces are there. So and there are buoyant forces, and that force of gravity is also there. So when this all forces are getting balanced and it is in a nice equilibrium position, we can say that the particle is got trapped, and you can manipulate that. And this is the first thing. The other thing is optical scissors. For there we are using the laser beam, and using a lens we will focus the laser beam and the focus laser beam. So that's a tiny focused beam can be used to cut or drill or do some dissection on the organelles or the cell components. We can do that cuttings and other things. And the main thing is that it is not to give too much heat to the nearby areas, such that it will be much more precise and less damage occurring thing. So these things we discussed. So here actually we discussed the optical teaser. So how optical teaser basics are working, and based on the light carrying momentum, and the change in momentum causes force, and there are like different methods which we used for the optical teaser thing, and the teasing action which we discussed here. So so if you have any doubts regarding these optical teasers and other things, so just mention here, and please put it as a comment or a question in the our Google Meet group, such that we can some will some TAs or the NPTEL team will see that questions, and if you have any doubts or any clarification required for that particular thing, is you can put it as a comment or anything. We will see that one and try to clear your doubts as well as the requirement. So hopefully these lessons are actually useful for you people. So if you have any doubts, please ask, and try to do all the assignment by yourself, and that will be useful for your examination purpose. So if you have any doubt, you can ask in that Google form. So now I am stopping. So wishing you all a happy learning and all the best. Thank you. So I am closing the meeting. Wish you all the best.